Except for
Welcome,
not
everybody.
exactly. Hi, everybody.
Well, that was a good start. We'll just talk over each other the whole session.
Sweet. That's exactly what we should be doing.
That's what happens when Bob's not here. We just fall apart.
Wait, what'd you say? So, hi, everybody. Welcome to this week's Tanzu Tuesdays without Bob. I'm sorry. He's in the middle of nowhere driving somewhere. So, we are taking over this time.
I did tell him he should call in from his car with his screaming family in tow, because that would have been entertaining for us. But he didn't seem to be as excited about the idea.
I'm seriously offended that he's not here.
Right?
Yes.
You're actually the first one he's missed, so I don't know.
Well, now I'm really offended.
Yeah, it should have been like having the video with the trees or wherever the heck he is, like as he's traveling over. Yeah.
Right.
He tried to sneak it in real discreetly to me. Like he messaged me on Sunday, like thinking probably I'm not gonna respond, it's Sunday or whatever. And I saw it and I was like, Bob, I'm really upset that you are not gonna be there. So I caught him in the act.
Nice.
So let's start with covering some of the upcoming events. So first, next week, we have our Tanzu Tuesdays covering getting started with Steel Toe and .NET microservices. There's Spring 1 tour, which will be in August. So that's August 19th through 20th. And it's microservices.next with Spring. And that'll be with Spencer Gibb and Nate Shuda. Then after that, we have Spring 1, which is our spring conference, and that'll be September 2nd through 3rd. And then we also have VMworld, which is September 29th through October 1st. And all of these things are free. So just go and, for the conferences, just go and register for those. And then for Tanzu Tuesdays, it's just like it is every week if you've been here before. Otherwise, come back next week as well. And awesome. Is there anything that you think we should cover?
Well, you're going to be speaking at Spring 1 Tour, right, Tiffany?
Yes.
Sorry, Spring 1 Platform. And Ryan, I assume you'll be speaking at Spring 1 Platform as well.
I am.
Kind of a big deal. Nice.
Well, some people tell me that, but I don't believe it.
Yeah. Well, I'm saying it right now because you're on our show and I feel like I need to blow a little smoke.
I appreciate it.
Paul, why aren't you?
Because I'm crafty enough to get out of it. I will be, however, I think helping MC at least one of the tracks, so people will hear my voice because the people do want to hear that. And then I will be speaking at VMworld, and I'm speaking at KubeCon in a couple of weeks as well. So if you want to hear me talk about, I think we're doing a deep dive into Helm, and so doing some of the like under the hood Helm stuff, how it works, etc. So that'll be fun.
You think?
Well, I don't have to have it done and recorded and sent until Friday, so I've got plenty of time to figure it out.
Okay.
What else have we got going on? I think that's pretty much covered all. Ryan, anything you've got going on that the people should hear about?
No, I think the next time I'm speaking, like you said, is Spring 1 Platform, and then I'm also speaking at VMworld. But from the Spring Cloud team, we have a couple of releases that are coming out in the next few weeks. So our latest milestone of Spring Cloud, which we've kind of renamed the release trains to be date focused. So it's the 2020 release, our next major release. Should be out this week, so keep an eye out for that. Some cool stuff in there. We love your feedback, and we'll have our next service release of Hoxton coming out either later this week or early next week. So some new stuff coming down the pipeline on that front.
Nice, very cool. And then I guess maybe Ryan, you could give us a little bit of who you are, what you do here.
Sure.
And what we're actually going to cover today.
And where you are. I see the AC, so I'm guessing it can get hot.
So yeah, I was actually just talking to someone about that, and I'm feeling the heat right now, actually. So I'm in New Hampshire, which most people don't really associate with heat, but it has been brutally hot here for New Hampshire for the past 2 days. I feel like I'm in Texas or Florida or somewhere down there.
Oh,
Like,
yeah, it's like it was here yesterday.
yeah, it was like
upper
close.
80s.
No, it was like
88 right
close
now.
to 100 yesterday.
Shut up, Paul.
And then
You judging?
today it's like 90 degrees, but the humidity is like insane, out of control. But yeah, this is
48% according to the internet.
yeah.
Ugh. No.
So I had to turn the AC off because of the noise in the background for the next few hours. But yeah, it's hot.
We appreciate that. If we see the sweat pouring from your forehead, we'll assume that it's the heat and not the nerves.
Yeah. But yeah, welcome to my home office. This is my home office, where I work actually outside of quarantine. I still work in this office, so I work from home most of the time. So I'm based in New Hampshire. I work on the Spring Cloud team in VMware, and been doing that for almost close to 4 years now. I think like 3.5 years or so. And yeah, I know Spencer has been on. He's one of my teammates, and Olga was on last week or the week before, I believe. So
Yep.
another one of my teammates.
We had the good doctor on as well.
Oh, Dr. Dave. Yes, he's actually the person who hired me originally. Yeah, so I've been doing that for a while. And today we're going to cover a little bit about Spring on Kubernetes. So something I've been focusing on for a little while now. And this is basically what we're going to go through today. Is a workshop that I put together, but I'm going to do it as a workshop style. I'm just going to kind of go through the workshop fairly quickly, and show you guys kind of a basic overview of how you would go about getting a basic Spring app running on Kubernetes. So kind of a quick introduction to that. And then, but all the material for the workshop is available, and I'll give everyone links, and I'm sure you guys can put links to that directly in when we post this stuff online, the replays. And you can obviously walk through the workshop on your own at any time with just any Kubernetes deployment you have available. And we're hopefully going to be doing another workshop live hosted by VMware, the Tanzu team quite soon. We had a lot of success in the last one, and so a lot of demand for it to be done again. So if you want to walk through it with me or one of my colleagues, that will probably be happening soon as well. So keep an eye out for that.
That's awesome, because it was definitely booked out last time, and there was a wait list.
Yeah, so I think we capped it at 50 people last time because it was the first time we're giving it. We wasn't sure how it was going to go, but it went really well. And like you said, there was a lot of demand afterwards. So we're definitely going to do it again and probably open it up to a wider audience as well.
And another really cool thing about your talk today is like we've had talks on Spring, we've had talks on Kubernetes, and this is the nice little like bridge between the two of them.
Yeah.
So
Right.
yeah, we'll let you take it away now.
Okay, cool. So I will share my screen. Let me know if you guys can see that.
Yep.
Okay, cool. So I'm going to skip the introduction to myself because I already gave that, but I just want to acknowledge my other teammates that helped me out with this. Like we already mentioned, Dave Sire helped me out a lot, and Alberto and Ali have been contributing as well. So they've been huge, played huge roles in creating all this material. So I just want to give a shout out to them for doing that. So basically what we're going to cover today is we're going to create a pretty simple boot app that should be fairly familiar if you're familiar with Spring. We're going to build a Docker image for that app, push it to a repo, and then basically show you how you can get that deployed to Kubernetes and get it up and running. And then we'll show you a couple different ways of doing that, some different tools that you can use that developers often find quite useful in the process of developing and deploying to Kubernetes. And then we're going to talk a little bit about external configuration in service discovery. We're just going to briefly touch on that. And then as kind of a more full-featured demo of getting a Spring app running on Kubernetes, we're going to deploy the Spring Pet Clinic app with a MySQL database to Kubernetes. Just something a little bit more interesting. Like I said, all the material that I'm going to go through today is available publicly on the web already. If you go to this URL, and I'm sure, like I said, we can put this in the description of the replay. This is where the notes that I'm going to be working from are there today with all the steps and code and command line things and all that fun stuff. So that's all there. So that's all I got for slides. The rest of the time, we're going to just be doing some demonstrations here in this platform called Strigo, which is essentially just a VM that I have running that has everything all pre-configured on it. This is what we use for the workshop. I'm going to give it publicly, but I'm just going to run through it on it today using this. So first things that you'll do here is, if you're not using something like Strigo, if you go to these lab notes here, you're going to install all the prerequisites for the lab, which are pretty standard. But there's links to everything you need to install. If you don't have them installed already, we need to configure kubectl, which I think everyone's familiar with, is the command line utility for Kubernetes, and choose a Kubernetes instance to use for the workshop. If you're doing this on Strigo, there's some stuff set up here, but we don't need to worry about that. I've already done it. And then we get to the interesting part of basically creating your boot app. And before I get started, because I can hear my children walking in the door from daycare, I'm going to apologize if you hear any child noises, screaming, crying, anything like that. They burst into the room. They've been known to do that ahead of time, but it's the life we're living in, quarantine life. So they are home. Hopefully my wife does a good job of containing them, but they escape sometimes. So. Anyways, back to the lab. So the first thing we're gonna do, like I said, we're going to basically create a boot app, and we're just gonna use start.spring.io, everyone's favorite place on the internet, to do that. In this app,
.spring.io.
Yes, exactly. I feel like he's in the room. The only dependencies we're going to have here are basically Spring Web and Spring Actuator, so nothing fancy that you don't already know about going on here. And so we'll go ahead and run this curl command here. And we're going to get into this directory first. So as you can see, if we look at what's in here, there's nothing, like I said, out of the ordinary, just your basic boot app, right? I also have a nice little IDE here in the browser. This is basically, you can think of this as Visual Studio Code just running in the browser. So if you're familiar with that, we can go and look here at the main application file. And again, nothing crazy, right? Nothing out of the ordinary, just your basic app file, and nothing crazy going on in your POM. If we look at the POM, it is using the latest GA release of boot, which is 2.3.2, which is quite interesting because as I was going through this yesterday, there were some changes in there that affected this lab. So I'm glad I went through things yesterday, because we would have been some ugly fiddling around live debugging session that was going to happen if I didn't do that. But cleared all that up, hopefully. But basically the latest boot release, and like I said, Spring Boot Actuator and Spring Starter Web. So that's what we got. And from there, the first thing we do is just add a REST controller, right? So like I said, all the code's here, so you can just copy and paste it like I'm going to do if you decide to walk through this on your own. And you can just dump it in here. And you can see that we're just adding a REST controller, a simple REST controller that's going to return hello world here. So nothing crazy, right? And we're just going to test that out and see if it runs. And everything should start up on port 8080, as you might expect. We download some dependencies. And once that's running, we can, so we should get back hello world, right? On internet, you're only talking to yourself. Should not take this long. Whenever there we go. I don't know why it took that long. There we go. So we got hello world back. Everything started. So it looks like our app is up and running, which is a good thing. So beauty of boot, very easy to do. We can check out Actuator as well if you want. You can see that Actuator is up and running on the app as well. So we just have the basic health and info endpoints exposed by default. Okay. Now, the first step in getting anything running on Kubernetes is to package it up in a container that you can then deploy to Kubernetes. So there's lots of different ways you can do this, but one of the benefits of using Spring Boot 2.3.x is that Spring Boot can actually do the containerization of the app for you, right? So that's now this build image goal that's part of the Spring Boot Maven plugin or Gradle plugin, either one, that will actually package everything up for you in a container and does all the magic layering and all that fun stuff so that you don't have to worry about any of it. And so if you just run that command, you'll see you'll do your normal build, blah, 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 and then tests will run. And then it's going to start packaging up the app into a container. So you get this build image goal running. So it's going to pull down a couple of images from the internet, which shouldn't take too long. And then it's going to package that all up into a container. So while it's doing that, I will take a sip of water.
And is it using Paketo or those build packs to do that?
Yeah. So one of the covers is using the, you can see here, Java build pack stuff, blah, 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 going by. But yeah, it's using buildpacks.io to do all that stuff.
Nice.
So there we go. We have our image done. And if we Docker image, right, we can see we have our image here. Kids demo app. Okay, so it was just built. So pretty cool, right? You don't need anything extra. Again, you that's just from what you get from start.spring.io, and you get that app, that functionality to build the image. So now we can go ahead and run that thing. And what did I mess up? Copy and paste errors, right? There we go. So this is just running the Docker container. And again, we can check to make sure that our app is working. So if we hit the root at 8080, we see hello world. And we also see that Actuator is working. So our container image appears to be working fine as well. And so, yeah, in the first few minutes, we've done a lot. I'm pretty happy with that. I don't know about you. But the next step is to push this to some kind of registry, right? So we need the container in a registry that the Kubernetes deployment that you're going to use knows about. This could be something like Docker Hub if you want to push it publicly, or it could be a private repo that your Kubernetes instance knows about, or if you're using something like Google GKE, you would push to the Google registry there, or same thing with Amazon, whatever you might be using. So here we are going to build and the image and use a build it. I actually have, so on this VM that I have running here, I have Kubernetes running, but also have a registry, a Docker registry running locally. So I'm going to push this image to localhost 5000. So I'm going to build the image again, and it's going to, then we'll go ahead and push that image off to the registry that my local Kubernetes instance knows about. And if you're looking for a really nice Kubernetes cluster to use locally, I suggest you look up Kind. That's what I'm using here inside this VM that I'm running. It starts up super fast. It's basically you do Kind create, and all of a sudden you get this Kubernetes cluster that's running. You can do a little bit more configuration to get a registry running locally. It's pretty much a full functioning Kubernetes cluster that you can easily start up, create, destroy. It works really well as far as for development purposes and for running through something like this workshop just locally on your machine without having to go ahead and create, accounts, different cloud providers or anything like that. So if you're a developer, I suggest you kind of check that out because it's pretty cool. So we're going to push this to the registry. It'll take a second. And then we can just check that it is there once it's done. So just, come on. Beauty of live demos is waiting for things to happen over the network. So if we look at that registry catalog, we see that we have our apps demo app, which is pushed there. So that's there now. So we have it in a registry. Now we want to get it to deploy to Kubernetes. So the first step in doing that, doing anything with Kubernetes, is really just creating a bunch of YAML files, which is always fun. But since the app is fairly simple, the YAML is pretty simple as well. So we're going to make a directory in our app called Kates. And then we are going to create a deployment. And I'll show this in the command line, just explain basically what it's doing. So we're basically going to create a deployment descriptor for our app named Kates Demo App with the image from our local registry here. That's the image. And then cut off my face, I guess. Should be /dry run. So this is a key here. We're going to output as YAML, and dry run basically says don't actually create the deployment, just spit it out back as YAML file to me, and then we're going to put that YAML in this Kates deployment YAML file. So if we execute that, and I think because I have the screen so big that some of the font's getting cut off. But if we look here in the IDE, we have a Kates directory, we have this deployment YAML file, and you can see there's nothing really crazy going on here, right? It's basically just has a name, and it has image of that's going to use for the deployment. And then what we need to do is do the same thing, but we're going to do it for the service, right? So the service is what is going to actually expose this container to other apps running in Kubernetes, or if you so inclined, the public internet. But this basically just adds a service that allows other applications to communicate with this app. So if we look at what that looks like in IDE, again, nothing crazy here. It's basically exposing a port 80, and it's targeting port 8080 because that's where our app is. The other maybe slightly important thing here is the type of the port is cluster IP. So it's basically saying assign an IP address that's only visible within the cluster to this app. And once we've got that, we're actually pretty much able to deploy the thing and test it out. So a nice little command line utility that's useful for this is called watch, which basically is going to is a Linux command that will execute this kubectl get all command over and over again, so that we can see things get deployed, see things change as that happens. So if I start that up, we can see we don't really have much going on here in our Kubernetes cluster. But when I go ahead and run apply the service YAML and the deployment YAML, we should see things actually get deployed. So if we go back to our terminal here, or the terminal window, in our watch command, we see our service that got created here. And then we also see that we have a new pod and deployment. Since deployment has spun up this pod, and it was just creating the container, but now the container is up and running. So how do we test it out, right? Because actually there is no external IP address for this thing. There's only an internal IP address that we can actually not get to. So if you're familiar with Kubernetes, you probably are familiar with this port forward command, which basically is going to allow us to forward HTTP requests from our machine off to inside the cluster. So if we execute this command, you can see we're forwarding localhost 8080 to 80. And if we you see we get hello world, right? And we also have actuator up and running as well. And spell it right. Actuator. There we go. Yeah, so everything looks like it's up and running, and we already have our app deployed to Kubernetes. So congrats, right? So it's a huge accomplishment. I'm very happy about it, and I hope everyone else is. It's glad to know. Yay, round of applause. It's almost like I'm really presenting to people. And yeah, so there's some other stuff that you can do here, which I'm actually going to skip over in this demo because it's not particularly interesting, because changing the cluster IP to a load balancer would allow us to get a public IP address for our app and then hit the app outside of the cluster, right? And so if your Kubernetes cluster supports something like this, it's a very simple thing to do. You're just going to change in the service YAML. Here you would go, right? So here where we have cluster IP, you would change this to load balancer. And this would actually, and then apply this service YAML to Kubernetes, and it would actually assign an external IP address to your app, so you could hit the app externally from outside the cluster, which is kind of cool, but doesn't really buy us anything from a demo perspective. So I'm going to skip a little bit about that. But if you want to do that, go ahead, and you can see here you get an external IP address, right? But some more interesting stuff happens below here, and that is around liveliness and readiness probes. And the reason why I think this is interesting now is because there's new support in Spring Boot 2.3 that has specific actuator endpoints for liveliness and readiness probes. So this is some of the new Kubernetes support that we've added to Spring Boot. And this is actually where we've made some recent changes where I got tripped up yesterday and things were not working. So there's these new properties that you have to enable where before they were not there in order to make sure the probes are exposed. And this makes sense. It follows suit with most of the other actuator endpoints and allows you a little bit more control as far as enabling and disabling things. But if we want to use these, I'll jump back a little bit. Why is this important? These liveliness and readiness probes. So right now, the way we have our app configured in Kubernetes, if the app for some reason became unresponsive or was having issues, right? Kubernetes has no idea about it, right? It also has no idea when this pod is starting, whether it's actually able to start accepting traffic, right? So whether it's ready or not, because we haven't told Kubernetes about that, right? And how to test that out. So these liveliness and readiness probes allow you to enable that functionality. So in our deployment YAML, we can say, hey, there's liveliness and readiness endpoint. Hit these endpoints, and as long as you're getting back a 200, for example, things are good, right? We're either ready or we are still alive and kicking. And if for some reason, for example, when the app is starting, the readiness probe cannot get a successful response back from that endpoint, it will try restarting this pod again and it won't direct any traffic to it until it is actually up and running. And the Liveliness probe will basically say, if this endpoint starts responding with anything other than a 200 or never responds at all, then maybe there's something wrong with the app and this pod, and we should probably kill the app and try restarting it and see if that fixes the problem, right? So it just allows basic health functionality. Basic health functionality is around detecting whether the app is up and running and actually able to do something useful. So it's quite important, just as basic cloud functionality goes. So like I said, we have these two endpoints, the /health and /readiness endpoints. And actually, if we were to hit those endpoints, you can see /health, right? /health/ oh, it's not there because I haven't enabled it. Duh. Got to do that first. Okay, so we got to go back. I was going to show you the endpoints, but we'll do that after. So we're going to add these properties to our application properties file. So back in our IDE, if we go to source main resources, application properties, here, we'll paste those in. We can see, get those properties enabled. That's all good. And we're also going to go ahead and add the readiness and liveliness probes to our deployment YAML. So back in our deployment YAML here, under the containers, we're going to add some more YAML. So it's basically saying, hit this, make an HTTP GET request to this endpoint at this port, and hopefully it responds with a 200, and that means everything's good. And same thing with the liveliness probe, right? You're gonna do the same thing, but you're gonna hit it at /health/liveliness. And so we got that there. The other thing that's kind of important to do when configuring a container in Kubernetes is to allow some graceful shutdown period so that before the shutdown of the Kubernetes destroys or terminates the pod, that we allow some time for it to finish handling whatever request it's actually might be in the middle of doing before it shuts down. And there's no real like standard here as to what the right amount of time is. You might have to customize this just for demo purposes. We say for 10 seconds, give it 10 seconds before you actually do anything. But you can play around with that. It's going to be dependent on your application. But that's another best practice that you're probably going to want to add for any application you deploy to Kubernetes. So we have that there. And then we also have the ability for, this is another new piece of functionality that we've added to in Boot 2.3 around also around, Graceful Shutdown is basically finish handling any in-flight requests. So if we happen to get a termination notice, we want to try and finish handling any in-flight requests that might be made to the application at that time before we terminate. So we're also going to add that to our application properties file as well. So, here. And from there, we want to build and deploy a new container, right? And a new image and get that running in Kubernetes. So the first thing I'm going to go back and do here is I'm going to kill this port forward thing that's going on. And we're going to do kubectl delete -f directory. That should kill the service in the deployment and eventually stop our pod. So it's terminating. And then I'm going to configure our boot application. So instead of, remember earlier, up here when we built our container, we had this kind of fairly long command. Where is it? Here. Nope. So further, I believe. Yeah, we have this fairly long command specifying this property, Spring Boot build image name, blah, blah, blah. We can actually make that a little bit easier just by adding that property directly to our Maven POM. So the next thing I'm going to do is go ahead and add this property here so that we don't have to keep typing that over and over and over again, which gets a little old. So in our POM, we'll go to the properties section. Add that. All right, so now our commands look a little bit nicer. So we're going to go ahead and build this image again. It should run a little bit quicker since we're not going to pull a bunch of stuff down from the internet. And we got that. Also, we have some nice layering going on, so that all works in our favor. And we're going to push that image off to our registry. So we have an updated image pushed off. Again, works really well because we have nice layers. And then we're going to apply everything. And so now we should have our, oh, you know what? I forgot to, I don't think it's going to affect anything, but I forgot to revert this change that I need. It shouldn't affect anything. But if I go to, let's do kubectl forward. Now, if we go to actuator/health, we see we have those liveliness and readiness probes up and running, right? So if I now go to /health/liveliness, we get that, and same thing for readiness. We have that up and running, right? So, and if for whatever reason that was not working here, you would see this container would actually not start, this pod would not start, and it would continually try and restart itself because the readiness probe was coming back with something other than a 200. And if for whatever reason, while this is up and running, the liveliness probe starts to come back with something other than 200 or never responds at all, again, you'd see this restart. So we can tell that it's working because it's not restarting. So those are very simple things that you can do. Again, all built into Spring Boot without any extra stuff. And it gives you a lot of pretty basic functionality that's quite important when you're talking about building cloud native applications. So we'll clean everything up again, and we're going to move on to some tooling that developers are going to find quite useful as far as building applications, right? So we just went through this kind of basic setup of, building, deploying, pushing, creating containers, all that fun stuff, right? And again, as a developer, you're making changes. All that stuff can get pretty old fairly quick, having to do that over and over again. So anything that makes that a little bit easier is going to be a welcome piece of functionality. And so we have this tool called Scaffold, which is kind of almost like provides a building blocks for like a continuous integration, continuous delivery process, which you can use in your CI/CD tooling, but it's also quite useful if you are a developer, and you're going to see why that is useful. But as with all things Kubernetes, see, there's my kids yelling, told you. As with all things Kubernetes, it is based off of YAML. So again, so you don't have to bash your head against the wall, I've provided you with the basic YAML to get started here. Actually, Scaffold does a very good job of generating this YAML for you when you don't have something like this provided to you. So if you did something called Scaffold init, it would automatically pick up, like, for example, that you're using, you're trying to deploy a Java app, and it looks for the POM file, and it does a lot of basic stuff for you that you wouldn't have to do. But yeah, I've basically provided the correct stuff for you here in the documentation. So we're going to go back to our IDE here and add a new file. Just want you to create a new file. Let me see. It's hidden down in the bottom. All right, let's do this a different way. So call it scaffold.yaml. And we'll paste in all that. Basically, all this is doing is saying this is how you build this application, and this is how you deploy this application. So again, as Paul pointed out earlier, we're using build pack to do that. So there's this new build packs thing in Scaffold. This is the builder that you're going to use, and here are where all your dependencies are located to build. This is the image that we want to, the name of the image we want to create. And how you deploy this thing is basically applying these YAML files that we have here, okay? So once you have that YAML there, you can deploy with Scaffold, right? So we can do this quite easily, which is a little bit simpler than what we were doing before. So if we do scaffold dev forward, I said dev instead of dev. This is a problem without having a live audience, someone to yell at you. Let me just typo. Ha ha ha, so funny. All right, so it's it's going to go ahead and build the image for us, and then it will go ahead and also deploy everything. So basically what would take us a couple of commands before is now done in one command. And the other benefit here is that we have that dash port forward option that we specified, and basically that automatically does all the port forwarding for us as well. So we don't have to execute that command either. And as an added bonus to all that, you'll see in a second after it's done doing this that it will actually stream the logs out to the command line window for us as well. So we get all that for free in one single command without having to do it ourselves. And as another added bonus, once we're done and we terminate Scaffold, it also deletes everything that it created. So the deployment in the service YAML would actually get removed instead of us having to clean it up manually. So this takes just a little bit the first time to build and deploy and all that stuff, but subsequent runs, it's quite quick. Just like after our initial build with the tooling that's built into Spring Boot as well.
Hey, Ryan,
So,
we just had a question in the chat.
Yeah.
And that question was, does Kubernetes open up the liveness response and read the JSON and look for up, or is it just accepting the status 200?
It is just, the way I had it configured is just accepting the status 200. I believe, and Paul, you can correct me if I'm wrong, I believe you can configure it to do other things as well.
Yeah, I'm trying to think. I've seen people where they'll have it call a script instead and have that script do something a bit more complex.
Yes, I've seen that as well.
But I've also seen folks set up the response to send just the headers with the 200 and not send anything in the body as a as a optimization.
Yeah.
But
yeah,
I think
so
for
by
a app like this, we don't need to worry about such.
yeah. So like Paul said, I have seen people set it up so it executes a script. And that script can do probably something that's a little bit more verbose than just checking the return code, the status code. Yeah, if you want to check for specific headers, that would involve probably customizing the Readiness actuator endpoint and Liveliness actuator endpoints from whatever their default operation is, which obviously is completely doable in Spring Boot, as you know. So you're free to do that as well. And you could create your own endpoint if you wanted to, actuator endpoint, and point it to that endpoint, which did whatever you wanted to, right? So there's lots of different options here, but by default, it's just going to look at the status code and whether it actually ever responds at all. There's also some stuff you can do as far as like timeouts, right? So how many retries it actually gives it and stuff like that from the Kubernetes side that you can configure as well.
Yeah, I've definitely had with the liveness check, you get in that loop where it doesn't start up in time, so the liveness check kills it, and then it doesn't start up in time. And like half an hour later, you're trying to figure out why nothing's working.
Yeah, when I see it start to restart itself a bunch of times, I know it's probably something with the readiness check that most of the time I've screwed up myself.
Right.
But yeah, it's a nice indicator that something's probably not going well with that. Which actually was the problem I ran into yesterday, because by default I said, I mentioned that those application properties weren't necessary in Spring, the initial 2.3.0 release of boot. And since we were just automatically, pulling whatever the latest GA release of boot is from initializer, between the last time I did this and now, it changed. And so I was just watching the application continuously restart when I deployed it. And I was like, what is going on with this readiness check? And came across that change. So yeah, fun stories. Okay, so I have to remember to change this back. You can see that Scaffold deployed the app, right? I mentioned that all the logs now get streamed out here to your terminal window, which is extremely useful as a developer and something we didn't have before. It also set up the port forwarding, right? So it exposed the port, blah, 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 on port 4503. So now if we hit, you can see we get hello world back. That's pretty awesome, in my opinion. And far less commands, right? One command to do all that as opposed to 3 or 4. So that makes my life a lot better. And the other cool thing that Scaffold does is, since we told it where our source code lives, it will watch those files for changes. So if I go into my IDE and I go back to my application file here and I change hello to hola, which is my extent of Spanish that I know. And then head back to our terminal window. Scaffold is going to automatically see that we changed that and rebuild the application. So rebuild the container, compile everything, build the container, push that container off to the registry, and then restart the application. So you can see eventually that once we get there, that this pod will kill itself. Yep, so the new container is creating. This one will eventually, once this one's up, right? So we're going to see this readiness probe in action. That's going to come up. This is going to come down. And once that happens, it should you should be able to hit the new application. So sometimes this takes just a little bit of networking magic time for that to happen. You can see there for a few tries, we got hello world, right? So I was able to make a change, and all that stuff that I was having to do manually before, rerun those commands, happens automatically for me. And again, from a developer perspective, that's like a huge win, time saver for me. So Scaffold is like extremely useful tool to me as a developer, and something that I think that every developer building Spring apps should probably use. And like I said before, if you kill this Scaffold process, we cleans itself up and everything, so that's really nice too. But what if you want to debug? Like, I want to set a breakpoint somewhere, right? I want to actually, like, something's really wrong with my application, which hardly ever happens for me, but there's other developers out there that might not be as fluent, right? So things go wrong. So what if I want to debug this thing? So can see. So we're just going to change that around. It's going to make things a little bit easier to debug, right? So what I'm going to do here is first, I'm going to set a breakpoint here. That's the first thing you do when you debug. But then we're going to configure our IDE to debug this application. So Scaffold has another command called debug, which is also not only going to expose a port for us to make requests to on the application, so do the port forwarding. It's also going to set up a remote debug port as well for us. So by default, the port will be 4503 and the remote debug port will be 5005, right? So if we run this command here, so again, the only difference here is that we're using the command debug instead of dev. Pretty much everything happened, the same thing, stuff will happen, but we will get the extra debug port available to us. So again, we will have our deployments kicked up here. So it's up and running. And if we scroll back and look here, we see we have port 4503 and also port 5005, right? So if I go back to my IDE and I go to my debug tab here, and I'm going to create a JSON file, and I have what I need in that file down here. So again, I provided everything you need. Oops. So I'm just going to replace what's here with what I have. And we're going to run attach. And it should be all attached. And if we go back here and we make a request in the terminal, should hit the breakpoint. You can see here we are on our breakpoint, which got hit. And because everything is so condensed and big, cannot find the the debug terminal. This thing's gonna time out before I actually get there. Anyways, you can step through the code and debug it just like you normally would if I could find the actual silly ass thing. I can't find it. Oh, there it is, the call stack. You see the call stack here, which again, you can't really see because everything is so, there we go. Here's my local variables, right? I could change this to back to timeout before I actually do this, but play. There we go, you got hello world, right? So that's a very quick demo of actually remote debugging. Again, I was able to debug it just like I normally would in an IDE. I can see the variables, I can see the call stack, I can manipulate things how I want to. And again, this is hugely, extremely useful for developers, looking to debug problems when their apps are running inside of Kubernetes. Very useful tool provided by Scaffold. So, all right, I want to keep moving on because I'm running short on time. I was hoping to be further along. The next tool that is quite useful for developers is Customize, and this allows you to basically type less YAML, which is always good. You can start layering YAMLs on top of YAMLs and make things a little bit easier as far as managing all that stuff. And basically customize stuff for, you can do like customize things for different environments, right? You have a dev environment, you have a production environment, you have a QA environment. You can customize what these deployments and service and config maps look like in these different environments. So what we're going to do is first make this directory called customize.base or /base. And I just did that in the wrong place. I need to destroy this and go. And then we're going to move everything from /Kate's over to right, and then we're so we look in our IDE now. Back here, we should have customized directory with just our deployment and service YAML. And again, customization loves YAML, just like all things Kubernetes, but basically we need to tell customize where our service and deployment YAML are located. So you do that by creating a new file called customization.yaml. And you plop that in there. And now this is one of the powers of customize, hence its name is to customize your Kubernetes YAML. So in this case, what we're going to do is say we have a QA environment, and in the QA environment, instead of one replica, we want to have 2 replicas of the app running. So we're going to create a customization for our QA environment. So we are going to create a new directory here called QA. Oops, WA QA. And inside of QA, we are going to create update replicas.yaml. And in update replicas.yaml, we are going to just specify how many replicas we want. So here, basically all this is doing is this, basically, it will make more sense when I show you this here. Siri just thought I was talking to her for some reason. I don't know why. Okay, distractions. Customization. So basically what we're saying here in this customization, we're going to take all the resources from the base directory, and we are going to patch those files with this update replicas.yaml. And what that basically does, so in update replicas, we're saying for our deployment, we want to change just the replicas. So the only thing we really specify here is that the replicas should be 2 instead of 1. So we don't have to copy everything, all the deployment YAML from our base directory and replicate it here in our QA directory. The only thing we really want to change is just the number of replicas. So we can see this pretty clearly when we start building out the YAML. So if you run customize.build on the base directory in our terminal here, it's going to spit out, hopefully, it's going to spit out all the YAML that gets generated here. And if we look at the deployment, we have a replicas of 1. But if we do the same thing for the QA directory, right, it looks exactly the same, but the difference is the replicas is 2, right? And the cool thing is now we can take this YAML that Customize generates, and we can pipe it right into kubectl. So we can say customize.build, customize QA, and then pipe that into kubectl apply. And that will go in and go ahead and create our deployment and service. And again, because we did the QA directory, we have 2 replicas being created as opposed to just one, which would be created in our base directory. But you're probably saying, well, we had all that cool tooling from Scaffold. I want to still be able to do all that. I don't want to have to do this again, blah, 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 blah. And good news for you is that Customize integrates with Scaffold. So we're going to just clean everything up here. And when we do that, we can go ahead and tell Scaffold that, hey, we're using Customize now, and that we should deploy things using Customize. So the only thing we're going to change here is in our deploy section of our Scaffold YAML. Here, so we go back down to scaffold.yaml. We're going to go ahead and switch that out to tell it to use Customize. So we have, by default, it's going to deploy what's in customize.base/base. But if we want to deploy to QA, we can specify a profile called QA, and in that case, it's going to use customize/QA. So we can go ahead and do that. For example, here, if we go to scaffold dev-p for profile QA, so -- port forward. So you can see it's deploying the QA profile, and it's creating 2 containers, right? So then if we go to watch, we'll see that those 2 containers are being created. And it gets a little confusing when you have more than one container because you actually have output from both of them coming out. So it can be a little tough to distinguish which one is which. You'd have to look at the ID here, right? So the pod ID is being specified, right? So that would be the only way of distinguishing which is what. And again, we only get one port, right? 4503, because what's happening here is Kubernetes is going to load balance between that on the service, right? So if you were to hit this, it's going to, I think by default, does round robin load balancing. But yeah, so we're going to load balance between those 2 replicas. Anyways, that's not really the point, but the point is that you can integrate Scaffold with Customize. So you get the best of both worlds for that. Now, the next thing I want to talk about is externalized configuration. And because I want to make sure we have enough time, I'm going to skip some of this and only go down to the interesting parts, right? Basically, the first section here is going to talk about one way of externalizing configuration using config maps and environment variables. But I'm going to skip down to the interesting part, which is basically having Customize generate our config map, mounting that as a volume, and then using that, right? So there's some other basic stuff that you can try out up above here, but I'm going to skip down to the cooler stuff down here, which is probably what you would end up doing anyways. So in our customize.base directory, so the basic use case here is I want to be able to customize or change the logging level via a property, right? So I can externalize this configuration to a file and use something called a config map in Kubernetes to host that properties file or YAML file in this case. So back in my IDE, again, I'm assuming that most people are familiar with config maps since other people have already talked about the basics of Kubernetes. In my customized directory, I'm going to create a new file called application.yaml, and I'm going to specify some configuration as far as what I want the logging level to be. So right now, I'm going to set it to whatever the default is, which is info, and then I'm going to tell Customize to generate a config map off of that application.yaml file. So in our customization.yaml, I'm going to add a new section down here called config map generator. So it's basically going to create a config map called dates demo app config with the contents of that config map being what's in application.yaml. So if we do customize, I'm going to do customize. Sure. Oh, customize the base stuff. We see that the YAML gets generated is, here is the YAML for the config map, right? So now we have this new piece of YAML that got generated for our config map. And again, we can take advantage of using that config map in our container that gets run. So basically what we're going to do here is create a volume for that config map. So it's a volume that gets mounted to our container with the data inside that volume being the data that's in the config map. And then we are going to mount that volume inside of the container, inside this /workspace/config directory. And our boot app is going to look in there for any external configuration and apply that to our application. So we will take this YAML here, and we'll go back to our IDE and our deployment here. And we're going to create, oops, not there, volume. Indentation is correct, or else we're going to be in trouble. And then we're going to mount that volume inside the container. So that can go here. All right. And once we do that, we can go ahead and scaffold dev, scaffold dev. And once that's done, you can see it created a config map, right? So created config map here. We can go ahead and do kubectl get. So we find the config map here. So we see the config map is created. And if we do show, we can see the contents of the config map, right? Cool. So we got that there. And like I said, it's initially info, so we don't see any crazy different logging going on here. But if I go ahead and change that config map from info to debug, yeah, here. If we change this to debug, again, Scaffold is going to come to our rescue and redeploy the config map with its the new value. And the streaming logs piece can be a little flaky at this point because it depends on the container getting restarted and if that all works out in a nice way. But sometimes you don't always see everything happening. Yeah, so it doesn't look like the logs are streaming yet. But in theory, if you, it kind of defeats the point, but in theory, if you restarted the pod and everything, you would see all these debug logs now coming out from here. But because I think it gets a little flaky when you start changing config maps out from underneath it, that doesn't always work. properly. Yesterday it worked for me, but today it did not. I've seen it not work in the past, but it could be a little flaky. But in theory, if you killed this process and restarted everything, you would see all your debug logs coming out. But that's basically the concept behind externalizing configuration to a config map for your boot apps. And now one of the last things I wanted to talk about was service discovery. So built into the platform, Kubernetes provides the ability to do service discovery. So when we make HTTP requests between different services in Kubernetes, you're basically going to use the service name as opposed to, an IP address or something like that. So what we're going to do here is I already have an app that I've created and hosted up on GitHub. It already has a customization.yaml, and so we can point to this customization YAML in our customization YAML for our app. It will deploy this app for us alongside of our app, and then we can make a request to it. And basically all this app does is it's a name service, right? So it just returns random names. So we can say hello to some random person instead. So in our customization YAML, what we're going to do is point to this new resource here. So customization. So here we're going to point to that customization. And what we're also going to do is go ahead and change our REST endpoint to make a request to that service. So you can see here is a little bit easier to read. Basically, we're doing to create a REST template and then make a request to this new service called Kate's Workshop name service, right? And that is the name of the service that we specified in our service.yaml for this application. So you can see this matches this here, right? So we'll just copy this code. Again, oops, not all of that. What was I? Not too far. Copy this. And I'm going to paste it right in here. And we will run Scaffold. And the other thing that you'll see that's kind of interesting here is that because we're deploying two services, that Scaffold will give us two port forwards, right? So one for the app that we're working on, as well as the other app that we're telling it to deploy as well, the name service app. So once that happens, so you see we have this name service app that's being deployed. Then we have two services being deployed here, one for our app, one for the name service. So we get logs again for that. And so we have two ports exposed. So our name service should be on 4504. So it should be 4. And you can see this just randomly returns some names. Leave it to you to guess where those names are coming from. And then if we then hit our app, which is running on 4503, see it's making requests off to that name service and randomly getting names back. So that's just a quick demonstration of service discovery. Again, nothing magical. We're just taking advantage of what the platform provides for us. So like I said, we have two services deployed here, one for our app, Kate's demo app, and then another one for our name service app. And the way to make a request to that app is just to make HTTP:// to this URL, right, which is the name of the service in Kubernetes. So if that all makes sense to everyone.
Hey, Ryan, can I just pop in with a quick question?
Sure.
Coda Prabhu asked, how do we compare storing configs in config maps versus Spring Cloud config server?
Great question. So it is a choice for you, right? Config maps are something that's provided by the platform. Again, so you don't need to deploy anything. It's just built into Kubernetes, etc. Right? But there are some nice advantages to using things like the Spring Cloud config server, which is backed by, for example, a source control repository like Subversion or Git. So when you externalize configuration there and you make changes to that configuration, you have versioning. It's easy to roll back. So you get a lot of different advantages to using something like Spring Cloud config server for externalized configuration as well, over something like config maps that are part of the platform in Kubernetes. So there is no right answer there. You can use either or. There's nothing that says you need to use config maps when you're running on Kubernetes. If you want to deploy a config server to Kubernetes as well as a Git server or talk to GitHub or whatever, that is perfectly fine. And you can do that as well. It's just a choice that you need to make based on your application and your architectural decisions, etc. But it would work. Spring Cloud config server works perfectly fine on Kubernetes as well. That's a great question.
And I might add to that if you're planning on doing some sort of GitOps type workflow, then obviously your config maps would also be stored in Git as well. And at that point, your decision, I guess, would be based around, do you have things running in multiple platforms that need to access the configs?
Sure.
So if everything is in Kubernetes and you're doing GitOps, then you might as well just stick to config maps. But if you happen to have stuff running in Amazon, AWS, like Elastic Beanstalk or something like that as well, then having that one place for them all to go to for config would start to make a lot more sense.
Yeah.
So I think, as you said, it's definitely more of an architectural question than like performance or best practices or whatever.
Yeah. So both should work. It's like I said, it's just a choice that you need to make. And the last thing, real quick, before we finish up, is I wanted to show kind of a more full functioning Spring app that something uses like Spring Data and backed by MySQL and caching, and Spring MVC is our kind of go-to Spring demo application, which is the pet clinic app, easily deployable to Kubernetes. So we've already mentioned Dr. Sire a few times in the webcast, but here we go again. He created basically a Dockerized version or a Kubernetes. I don't know if that works, but a version of the Pet Clinic app that's easily deployable to Kubernetes, hosted on GitHub. And he has customized files for all that fun stuff. So yeah, all we really need to do is run this command here. You could, again, do this in any Kubernetes deployment you wanted to, as long as you have customized installed in kubectl, and it's going to spin up Pet Clinic. So it creates a couple config maps, creates a couple services, creates a deployment for the app as well as MySQL, persistent volume for MySQL as well. And you can see all the stuff gets created in our cluster, which we have a nice error, right? This is a good example of the readiness check running, right? So I think sometimes it takes a little while for the app to realize that it has a connection to the MySQL database. So the readiness check comes back with a 404, but you can see it should eventually start itself up here, hopefully. At least it worked yesterday, so looks like it's doing something different.
Now, while that's loading, I was just going to quickly mention that I believe kubectl comes with a version of Customize installed.
It does.
It's not right at the latest version, which will sometimes cause issues, but often you can do kubectl apply -k and just give it the URL, and you'll get the same functionality as doing the Customize build pipe to kubectl apply.
Yeah, it's a good point. When I originally wrote the lab, it was a few versions behind it, it was not working.
Yep.
So I defaulted back to making sure we had our own version of Customize installed and just piping it into apply. But it might be the case now. I haven't checked, to be honest with you, that it is working. But that is a good point. That's a good suggestion as well.
Yeah, I definitely think it's that thing where if what you're doing with Customize is really simple, like just a little bit of overlay or whatever, the version in kubectl will probably just work fine. But I'm guessing you're doing a little bit more than that.
Yeah, and like I said, it was actually a while ago that I tried it, so it could be that everything's in sync now. But yep, that's a great point. Here we go. We should get this to show up here. And so we see our app, right? We can, should work. Oops, can't even spell my own name.
You know it's bad when you can't even spell your own name.
I'm not going to spell my real address either.
What, you don't want people shipping you weird stuff?
I mean, if you want to ship me something cool, I'll be happy to tell you my address, you know, privately. But what? Oh, maybe it's because I put dashes. There we go. Yeah, so you can do. So what's the format? I can't remember. Day for
It's month-end day.
Yep, so that's all persistent in the database. Oh, what did we do? Oh, last name. So, yep, just a quick demo of a more full-fledged app running in Kubernetes, Spring app running in Kubernetes. And that's all I really got. Like I said, there's a bunch of information here about exactly what's going on in that customization YAML if you want to check that out. And that's all I really got. You know what, I didn't mention, if you have questions, comments or feedback or anything like that, you can always reach out to me on Twitter. I'm at Ryan J. Baxter on Twitter. Follow, yell. If you want to send me something cool, direct message me and I will give you my address. But that's all I got. Yeah, I appreciate everyone's time.
Awesome. Thanks for going over all of this.
Yeah, no problem.
There's a lot more exciting having you go over it than just me doing it on my own.
And then the environment getting taken away from you, out from underneath you. Yeah, sorry about that.
Cool. Do you mind unsharing your screen?
Oh, sure. Yeah.
Let me just fix this up real quick. There we go. Oh, I'm on the big screen. Hello. Okay. So I think that has wrapping us up. Tiffany, anything we need to mention on the way out other than reminding people to like and subscribe or whatever you do on the Twitch? Favorite and notify? I don't know.
I can't think of anything at the moment, and chances are my internet will cause my video to freeze at any given point in time.
Right. Well, in that case, I guess we can just wrap it up. So thanks a lot for being on, Ryan. Tiffany, as usual, it's been wonderful. And we will see everyone again next Tuesday.
Everyone.
Bye.